In this lesson, we're going to look at changing improper fractions to mixed numbers. So first of all, why do we want to do this? Basically, the reason is because when you give somebody an answer, particularly verbally, the human brain makes a lot better sense out of mixed numbers than it does improper fractions. So, for example, if I say that my wife is 5.5 feet tall, everyone understands what that means. However, if I say that she is 11/2 feet tall, you're probably going to kind of scratch your head at me. Now 11/2 and 5.5 are exactly the same thing, but we can agree that 5.5 is a much better way to say it. So that's one motivational reason for wanting to be able to change improper fractions to mixed numbers. Now what I want to do here is up at the top here I give a general rule for making this change. But before we get into that rule at all, I just want to draw a picture so we have an intuitive understanding of what's going on here. So when I take 8/3, well, I need to have wholes that are broken up into 3 equal pieces. Okay, so here is 3/3. Okay, but I need 8/3, so I guess I better make another little block here that represents a whole. And if I color all 3 of those in, that gives me a total of 6/3. I guess I need one more box. So now if I color in just 2 of these, that's going to give me the 8/3 represented in that fraction. Okay. So this is 8/3, but I think we could all agree that I've got 2 full blocks here that are completely colored in. So I don't think it's a big stretch of the imagination to say, all right, well, I have 2 wholes and an additional 2/3 more of a whole. And so right there's our mixed number. 8/3 written as a mixed number is 2 and 2/3. All right, now let's look at what this process up here is describing, and then we'll kind of reconcile the two. What it tells us to do is divide the numerator by the denominator. Okay, so the numerator is 8. We're going to divide that by the denominator, which is 3. So to divide, you'd say 3 goes into 8 2 times. 2 times 3 is 6. And then we have a remainder of 2. So what this process describes to me is take the quotient as the whole part. All right, so my quotient here is 2. So that is going to be my whole part. The remainder should be the numerator of my fraction part. And then finally the denominator. Oops. Denominator here, or sorry, the divisor is the denominator. Alright, so let's see why this makes sense in the context of that picture. So when I fill in 2 of these, what I'm saying is that 3 goes into 8 2 whole times. So that's where I get this 2 from. It's also where I get the 2 from in this division problem. 3 goes into 8 2 whole times. And then the fact that I have 2 down here is saying that after I put 3 into 8 2 whole times, I get 2 left over. So there's 2 more I haven't accounted for yet. And all along I'm breaking it into 3 equal pieces, so that's why it's still appropriate to keep this divisor, or the bottom of the fraction, still as the bottom of the fraction. So hopefully that makes this division process make sense and where all the parts of it go. Because when I get to something like 53/8, I'm not that interested in drawing pictures anymore. That's going to take me a long time to do. So let's just try turning 53/8 into a mixed number by simply using this division process. So we make 53 the dividend, 8 the divisor. So let's see, 8 goes into 53, looks like 6 times. 6 times 8 is 48, and we get a remainder of 5. So this is telling me is the quotient, which is 6, becomes the whole. The remainder, which is 5, becomes the numerator of the fraction part, and the denominator is 8. So I get 6 5/8. And then lastly, let's look at a situation where we've got 15 over 15. Here, I suppose you could do this division process, but I think we can be a little more on top of it than that. 15 over 15. One thing that I haven't described yet in the videos is that fractions are just division. Okay? It's no accident that we used to write division problems using this fraction bar as well. And so 15 over 15, well, that's just 1, because 15 goes into 15 one time. And so it's just one whole. And that's why, of course, it says change each improper fraction into a mixed number or whole number.